Hello, Algebra 2. Today we're going to be talking about something called an arithmetic sequence. So, in order to determine what an arithmetic sequence is, let's look at the definition. So, according to Google, an arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant. For instance, the sequence 5, 7, 9, 11, 13, 15 is an arithmetic progression with a common difference of 2. So basically, it's just any sequence that you're going to be adding up the numbers as you go along. So let's look at an example. So this would be an example of an arithmetic sequence. As I look at my terms, I see I go from 2 to 5, 5 to 8, 8 to 11. And every time as I'm going up, I'm adding 3 every time. So if I wanted to know what the next two terms were, I would just add 3, and then whatever that was, I would add 3 to that. So notice every single time I'm adding 3. So the next two terms would be 14, and then 17, and then 20, and so on and so forth. So this would be the exact idea of arithmetic sequence where you can guess what the next terms are going to be. Now what we need to do next is look at some of the common definitions, some common terms that we're going to be using throughout these sequences that we're going to be talking about. So when we're talking about sequences in series, there's some definitions that we want to know. A sub 1 means the first term. Okay, so that's the first term in a sequence. Because it has this number 1 right there, it's going to say any series has its first term. So this 2 right here would be the a sub 1 in our example. A sub n means the nth term. So that could be like the 26th term if I say a sub 26 would be the 26th term. And lastly, this d means the common difference. Common difference. Now a common difference in this example, to go from 2 to 5, it would be 3. To go from 5 to 8, it would be 3. 8 to 11 would be 3. So the common difference in this sequence would be 3. Okay, let's look at an example. So as I'm looking through this example, I can see that my a sub 1 is going to be 10 because that's my first term. I then know that as I go up, my common difference is going to be 2.5 because I'm going to be going up by 2.5 every time. Now, if I want to know what was the 32nd term, or a sub 32, that might take a really long time for me to just count up. So the way that we can do this is by finding the formula for this. Now the way that we find the formula is we start with a sub 1, because this a sub 1 is going to be what we want to start at 10. And then we're going to add the common difference, but every single time we know it's going to be n minus 1. So if it was the first term, I wouldn't add any common difference. It would be 1 minus 1 or give me 0. So this part right here, this d times, it wouldn't affect it at all. But if it was the second term, so it was 12.5, I would multiply the common difference by 1, and I would get the 12.5. So in this problem, my generic formula would be that a sub n equals 10 plus 2.5 times n minus 1. Okay, now if I wanted to then figure out what was the 26th term, I'm just going to plug in 26 into here. So let's look at that. So to find a sub 26, it's just going to be 10 plus 2.5 times 26 minus 1, or 10 plus 2.5 times 25. And then 2.5 times 25 gives me 62.5. So this will be 10 plus 62.5, or 72.5. So that means that in this series, or in this sequence, 72.5 is the 26th term of this because I plugged it into my equation that I found from my formula. Okay, let's look at one more example. Here I have my sequence 15, 13, 11, 9. So now that my a sub 1 is 15 because that's my first term right here. Then my common difference is going to be negative 2 because as I go down negative 2 every single time. So this common difference doesn't always have to be positive. Sometimes it can be negative. So let's come up with our general formula. I know a sub n equals my first term, which is 15, plus negative 2 times n minus 1. Or I could write that as 15 minus 2 times n minus 1. So this now is my generic formula for this sequence. So I can now figure out what is the nth term. So if I wanted to figure out what is a sub 32, or the 32nd term, all I do is plug in 32. So I get 15 minus 2 times 32 minus 1, or 15 minus 2 times 31, or 15 minus 62. And that means when I finish solving it, I get negative 47. So this negative 47 then is the 32nd term. So if I went down here and I subtracted 2 37 times, or 32 times, I would get negative 47, or my answer right here.